All right, well, I think I'm going to go ahead and get started here. Um, just welcome to the Probe 5 webinar. I'm John Gray. I'm the Director of Research and Development here at Vsoft. And today we're going to be talking about Probe 5. I'm glad you guys are able to join us. So we've got kind of a mix of people in the group, some people who haven't really used the program at all, and some people who are, basically experts. So I'm going to kind of try and start off with just sort of a little run through of how things work on a basic level, and then kind of get into some more advanced stuff. I had requested if anybody had any questions or things they wanted me to talk about. So I'm going to try and work in, some people sent me some things. I'm going to try and work those into the presentation. So without any further ado, I want to turn my screen sharing back on here and let's go ahead and jump into it. No, that's for later. All right. So here's Probe 5. Oh, one thing I forgot to mention is if you do have any questions about anything I say, you can unmute yourself and jump in, or if you want, and probably preferably just put something in the chat window and I'll see it here and try and respond to your question. So here's the main Probe 5 window. When you first open it up, it's basically just a blank window. You've got our welcome screen here, which has recently accessed files. It shows your FM and TV database dates down here, and then we have this quick study option if you just want to do a quick study for a station without having to go through the main wizard. Probe uses a wizard-driven interface for doing new studies. So if you want to do a new study, you can click on this link here, create a new study, or go up to File and choose New Study. So Probe is our premier propagation analysis and interference calculation program, and basically mapping. So there's a number of different studies you can do when you go to create a new study. There's coverage study, TV interference, FM interference, and then some kind of specialized things, DDU study and a service counting and general interference, and then importing. So I'm just going to mainly talk about the coverage study today, just due to the limited amount of time we have. And we'll get quite a bit of the workings of the program that way. So you pick the type of study you want to do and you hit next. And this kind of runs you through step-by-step setting up your study. So you can select which terrain database you want to use. You can select which datum you want to work in, and then your cell spacing. And this, I'll talk a little bit more about these two items later. And then there's an option to use land cover data if you want. If we hit next on this, it takes us to our calculation area setup. Basically, you need to give it a value as far as how far out to calculate the signal. So you want to pick a value here that's probably beyond whatever the area that your station will go. And this is just a starting point. You can change this later on, but you have to give it somewhere to start with new stations. So I'm just going to go with this default circle radius 100, just to show you what the other options are here. You can do a circle, you could do within an FCC contour, noise limited TV contour. Then there's a couple other, like a lat long box and a polygon set are more advanced areas where you can kind of specify another area. And I'll talk about those a little bit later too. So next we get to our station list. Now here is where you add stations to the study. You can always add stations later, but you got to give it one station to start out with. So essentially this list box here is where you can put in as many stations as you want. We use the add button. This takes us into our transmitter editor. Here you could go in and put in your call sign, latitude, longitude, power, frequency, all the details for your stations. There's a number of tabs up here at the top. The antenna tab is where you specify your antenna patterns. Info has some additional information. Most of this comes out of the FCC database. And then there's this measured data is actually part of our optional measured data module where you can set up your measured data, and then Longley Rice parameters, the token settings, and then this custom HAT is kind of an advanced feature where you can override the values that it calculates using the terrain database. So to go back to our main transmitter tab, there's a load from station database button, which is a pretty good starting point. That will actually allow us to search the FCC's database. So up here at the top, we pick the database. We can do TV or FM. You can search by state, or you can search the entire database, and then search for, you can put in any string in here. You can put in a call sign, you can put in a licensee, you can put in a city, any string that's within the FCC record, it should match up with that. So if we put in San Francisco, I'll just put it in San Fran for short, I hit find, it'll pull up all of the matches that it found for that. Now, I've been working, one station that looks pretty nice that I'm going to use for our demo today is this KA. No, that's not it. It's KALW. So I just put in the call sign, hit find, and it found it in the database. If you click on this little details tab, it gives you some more information about the station. So you can make sure, sometimes if there's more than one, you might want to verify that you're getting the one that you want. So we just pick that and hit accept, and then it loads all of that information into our transmitter editor here. So we have the power, we have the antenna base elevation and height above ground. It's channel 219. So we've pulled all this stuff in from the database, so we don't have to type it in manually. So I'm just going to go ahead and hit OK to accept this as the station we want for our study. And then at this point, we could add more stations. For now, I'm just going to go with this one. So I'll hit next, and then we'll hit, and then basically it's telling us, okay, you're done setting everything up, so hit finish to continue. And when we do that, it's going to take us into the main part of the program. Up here at the top, there's a progress bar. That's the Longley Rice signal calculations. And when that gets done, it pops up a little window and asks if we want to redraw. So I'm going to go ahead and say yes. So the main screen in Probe has, kind of a number of different elements to it. The main element here is where we've got our map. This is where, this is a page style WYSIWYG type of thing. So when you print this out, or make a PDF or whatever, this is exactly what it's going to look like. And this shows, our field strength and our transmitter and our various other data. On the right-hand side over here, we have our transmitter list. This is where all the transmitters in the study will be listed. And you use this to get in, and you can access them to edit them or add contours or whatever. And then down here at the bottom is our field strength section, where this basically is where you're going to specify how you want to color code the visualization of the calculated field strength. So in Probe, there's kind of two main things that you're going to want to look at in terms of field strength. There's your grid-based signal, which is where we're going to go out and create a grid of cells, and then at each cell we're going to look at the profile between our transmitter and that cell and perform a field strength calculation to determine what the field should be at that cell. The other kind of method that people use is sort of the line style contour method, which would be like your FCC contours, where instead of looking at a cell, you're just looking at your transmit site and generally computing the height above average terrain on each radial, and then computing a distance that a particular field strength contour will go from that. So just to kind of show you how you get into that. So this signal we have plotted here, and let me zoom in just a little bit. There's a zoom tool. You can just click on that and zoom in. So what we have plotted here is the Longley Rice signal. So it's done on a cell-based basis. There's this purple is sort of 60 dBu, the orange is 80 dBu, and then the red around our transmitter site is above 100 dBu. So on that, this is where it's gone out and created a grid of cells and calculated the field strength in each cell. If you wanted to do like your FCC contour, what you can do is go over here to our transmitter list, and then left click on it will bring up, right click on it will bring up a menu here, and there's some options. So one of them is add contour. So up here, there's the contour type, and we've got a number of different contours. You can do an FCC contour or a circle, or There's some other special case contours. You can import a contour if you have like a data file for the contour data. So FCC contour is the most common one. You set up your location and time variability, and then you set a field strength. So like we can do 60 dBu here. I'll do that, say okay. So here is our 60 dBu FCC contour. You can add another contour if you want. I'll go back to add contour and we'll add the 70. Say okay, and then say okay on that. So we can kind of see here's our 60 and 70 dBu FCC contours. So one thing to keep in mind when using probe is that it sort of treats the grid-based calculations and the contour-based calculations kind of independently. So parts of the program deal with the grid-based stuff and parts of the program deal with the contour stuff. That's kind of important when it comes to generating pop reports and things, because depending on how you generate the report, in some cases it's going to use the grid-based, and in some cases it's going to use the contour-based. So it's just important to understand that that's how it works. And I'm going to talk a little bit about population stuff here in a little bit, so I'll get into that later. So basically, the other parts of the program up here, there's a toolbar. This section here, kind of in the middle, is where all the map tools are. These are all interactive to the program, and then the part here on the end is basically shortcuts to various kind of major features of the program. So the map features is probably the one you'll use the most. That allows you to configure all of the settings for how the map is drawn and how it looks. So that's, and this, just to point out, there's a number of tabs up here at the top where you can get in and change the settings for different things. That's another thing I'm going to come back to in a little bit. So I wanted to start off talking about, and this is sort of jumping into more of things for the more advanced users, the people that have the program. One of the things we recently released was the 2020 census geography data. So that's got the new city boundaries and county lines and things like that from the 2020 census. So I just wanted to do a quick kind of run over how do we use that data once it's installed. And so, once you've purchased and installed it, if you want to use it, there's a couple of different ways you can use it. And primarily, so like this map, you see all these yellow areas here. These are city polygons. So if we want to use the 2020 data for that, we go into our map features. Like I said, I use this little globe button up here. It's also, if you go to map, and then there's a menu item here, map features. So if you wanted to use the 2020 data, what you would do is go over here to this data sets tab. And this has, for your metropolitan areas, your county data, and your political data. And then there's a drop down, and this shows all the data that's available in the program. So right now, I actually have this map already set up to use the 2020 data. But if you had just installed the data, you'd need to go in and set this up to change these to do these if you wanted to use it. And if you wanted to use that as your default, what you would do is you'd select the data you want to use and make sure this is how you want, and then you can go down to save features. And if you save it as a color scheme called default, then when you create a new map, that's what it will use automatically. So there's a number of different items in this 2020 data. There's a metropolitan divisions, cities, this urban area cluster. This one of the things about the urban area data is it is using more of the definitions from the previous census. The Census Bureau is working on kind of revamping how they do the urban areas. So at some point, they're going to release a new set of urban area data that's based on the 2020 census that was taken. And we will make that available when it happens. But so if we just, I'm going to pick just to pick one of these, like, well, we'll just put it on the urban area one so we can see what that looks like. So So when we draw the map here, we notice we don't have our cities up here. It's got the urban area. So that's kind of how you get in to do that. The second way you would use this data is if you're looking to do something specific to a city or an area where, say you want to show how much of a city you cover, you would want to look at, an individual area. So the way you would do that is actually you go into map and then add to map. And then there's a couple ways. You could do this new polygon or polygon from map data, but that only loads a single polygon. The kind of preferred method for loading these is you go into a polygon set, because some of these areas are complicated areas that may have several polygons in them. And if you use one of these just normal polygons, you can only load them one at a time. But if you use a polygon set, you can work with all of the polygons at once. So once you get into our polygon set, and a polygon set is basically just a group of polygons that have a common property. So you can, deal with them individually here, but there's a button on this window that says from data. If we click on that, it takes us into our polygon loading function. And again, there's a drop down and you can kind of pick the data you want to load from. So let's look at the 2020 city place boundaries, and it's going to load the data, and then it has basically a search window. So like on this map, for this station, let's say we want to look at Oakland, California. So we can put that in the find and it'll search and find it here. So it found this one just has one polygon, which is good. So we're going to hit OK. So we've loaded that into our polygon set, and then we can set the way that it's drawn, the pen style. Well, essentially that's the boundary that's drawn, and you can also tell it to fill in the polygon if you like. I'm not going to turn that on just yet, and then there's a option down here at the bottom for lock points in place, which actually I'm going to turn that on so that this will prevent us from clicking and accidentally modifying the polygon once it's on the map. So if we hit OK on this, it's going to show our polygon, and we can see it right here. So I'm going to zoom in a little bit more. So here is our Oakland polygon. This one's kind of interesting. I'm going to, so we've got our Longley Rice up here. If you want to turn that off and not show that at any time, you can go over to the transmitter list and uncheck it in the list. And then there's a button down here, this force map redraw. We'll redraw it. So in this case, our Oakland polygon is kind of interesting because it has a hole in it. There's this Piedmont's actually a separate place, and so there's a hole. So if we go into our, I'm going to turn off our metropolitan areas in here. And actually, we still can't tell that there's a hole there because we didn't fill it. So if we double click on it to get back in here and choose to fill this polygon, and I'm just going to say, you can choose the layer that it's filled on. If you do one of the lower layers, you have to do a full redraw of the map to get it to fill in. If you pick one of the upper layers, it will just fill it automatically. So here you can tell we've got our polygon, it's got a hole in it. And this is one of the differences between the 2020 data and the 2010 data that we released. The 2010 data does not appropriately deal with the holes, and the 2020 data does. So now we can see, there's a hole there, and so when we're working with the polygon, it's not going to count the people that are inside that hole. So if you wanted to get the population just for this polygon, we can double click on it to get back to our properties, and there's a pop report button here, and that will give us our polygon total. So we've got 440,651 people in that polygon. Now, of course, there's, say we want to figure out what our coverage of that polygon is. So you can see this is our 70 dBU contour, which I put up here earlier. And I'm going to change this now to plot it on a lower level. And then we'll redraw that way. We can see our contour go over the top. So you can see our 70 dBU contour covers part of the city, but not all of it. So if you wanted to figure out how much of the city you are covering, the way you would do that is we have a tool called the contour overlap tool. And that's, if you go on the tools menu, it's right here, or there's a button up on our toolbar. If we click on that, it'll take us into that. So what we can do is build an overlap region that has that. So what I did is I'm go back and explain what I did here. So this contour overlap region, you can create as many as you want to study. So this is sort of our list of overlap regions. So when we click on create a new overlap region, that'll take us into our overlap editor. And here, basically, you select the contours you're interested in. So here's the 70 dBu FCC contour. And if we pull this down, it's plist is our polygon list, and here's Oakland. So we can move that over. And then the type, you can do the intersection or the union. In this case, we want the intersection. And then we can fill it in. I'm going to have it filled in with, we'll pick green here. Say OK. And so now here it is in our list. So if we hit close on this, it's going to show us. So now the overlap area we defined is this green area. So we want to know what the population is here. So what we can do is go back to our contour overlap list. And this is an example of where, kind of, depending on where you tell it to count the population, you're going to get different results. So here, since we're dealing with a contour overlap, we go to our contour overlap window, and there's a population report button here. So we select the area we want. We say population report, and then we hit OK. And it's going to go ahead and count the pop. So in this case, the total population in that overlap is 255,000, and it even has a summary down here. So we looked at our polygon and we saw the population there was 440,000. So in this case, our overlap area is 58% of the overall city. So that's kind of how we can go in and quickly determine. And it has a percent of the population and the percent of the area covered. So it's a little less than 50% of the area and a little more than 50% of the population. So I'm going to close this. So the next thing you might want to do here is say, okay, well, we figured out based on the FCC contour what the coverage is of the city. What about if we wanted to look at our Longley Rice? So to do that graphically, I'm going to go back to our contour overlap regions here and delete this area that we created earlier, just because we don't want to deal with that right now. And then I'm going to check this box and hit redraw. Actually, I'm going to go in and change if you click on the field strengths down here at the bottom, that's how you can edit those. So, right now we have 3 field strengths shown. So in this case, just to kind of make this cleaner, I'm going to go in and pick just the 70 dBu, and we'll make that red so it's real obvious. So now we can see, and actually in this case, visually, you can see the 70 dBu covers pretty much the whole city. So for the sake of example, let's say instead of 70, we're interested in the 80 dBu coverage. Oh, actually, I take that back. It didn't cover I have my city filled in with red. That was an unfortunate color choice there. So let's redraw that. So here's our 80 dBu. You can see it fills in most of that. And actually, let's go back to the 70 and see. So I don't think it quite covers the whole area. No, it doesn't. So here you can see that the red is our 70 dBu, and it fills in almost all of Oakland, but not quite. So if you wanted to find out how much of your polygon is filled in, there's a special function that's part of our population report. And I actually meant to talk about this first, but since I'm already into it, I guess I won't. So, well, actually, I will. So just let's say we just want to know, what is my coverage of KALW and in terms of this Longley Rice signal, not the FCC contours. The way you do that is up here on the report menu. There's a population. So this population, when you click on that, it says grid-based signal population report. So this is based on the grid-based signal. It doesn't have anything to do with the FCC contours. It's just the grid-based, which we did Longley Rice for. And you can also there's a button up here on the toolbar that'll take you to this grid-based signal population report. So here's where you can put in, there's a number of different kind of reports. There's a simple report, county breakdown, and all that. And then there's some options here. So here, let's say we wanted to do the 70 dBu. um, report. And this is something that's new actually to the program fairly recently. Down here at the bottom, there's some options for the output. You can do a text report or you can do a tabular output. Actually, I'm going to do the county breakdown report, and I'll leave both these on. This is also new over here on the right. There's a list. You can turn on and off individual transmitters to be included in the study now. So if you had some that you didn't want to include, you could uncheck them here and it would basically ignore them for the pop report. So if we hit generate, it's going to pull up two windows now because I had them both turned on. So there's our text window, which gives you our standard text support. So we can see our 70 dBU coverage is 2.8 million people. And then it gives you a county by county breakdown of the coverage. And so this is using the cell-based along the arrays. And then it also will generate a table for us, which the table is nice in that if you wanted to save this for something to bring into a spreadsheet or use that way, you can generate this table, and then down here, this actions button, you can actually generate a text report of the table, but there's also save data to CSV file. So if you wanted something that you could put into Excel or whatever, you could save this to a CSV file and then pull it into there. That's something that was somewhat recently added to the program in the last year or so. So to go back to what I was talking about in terms of if we wanted to know within this polygon what our population coverage was, that is also up here on our pop report window. There's this item down here about only count area inside overlap region. So right now, count all area is our only choice. So what we need to do is create an overlap region with that polygon. So to do that, I'm going to go back to our contour overlaps window, and I'll say create new region. And I'm just going to move just our Oakland polygon into that. Actually, I'm going to uncheck this so it doesn't plot it. I'll say close. All right, so now I've created a region that just has that polygon in it. So when I go back to our population report, we see we have an option now to only count the area inside that Oakland thing. So if we put this on 70, say generate, then we're going to get a report that has 423,000 people, or how many in there, and I believe there was 455,000 in the polygon total. So in this one, to get the percentage, you'd need to go in and compute the polygon separately. All right, so so that's another that's a more advanced feature, obviously, of how you do that. But that's something that I get asked about fairly frequently is, how do we determine, what the coverage is within a particular polygon. The one other thing I wanted to talk about on our pop report, on this grid-based signal pop report, you can set up these things, like maybe do you want to do the county report by default or the simple report by default, or some of the other options in here. You may or may not want to have those on by default. There is, when you've got this set up, there's a new button down here at the bottom that says save current settings as defaults. So that's, like your output. If you only want the table, you can turn the text one off, or if you only want the text one, you can turn the table one off, and then save those as default. So the next time you pull up this window, it will use whatever you had selected there. Let's see here. What other things were we going to talk about? So yeah, so that's basically how we can work with our data. And then I'm kind of done with this polygon, so I'm going to select it and hit delete. I had several questions from people just sort of wanting me to talk about just in general the map features and setting up your maps. One of the questions I got was, how do you make a good looking map? And that's kind of somewhat subjective. One person's idea of a good looking map may not be another one's. I guess I would suggest on that, go out and find some other maps that you think look good, and then you can work with our map features here and try and design something that looks similar. This is designed to be pretty flexible. So for example, there's all the different layers, you can turn them on and off using the check boxes. And then there's a change button over here. When you go into that, you can set the border color and the fill color, the border width, the border style. You can do dotted or dashed lines. And then there's a option to fill it or not. So it's fairly flexible. As far as the colors go, again, that's sort of a personal preference for a lot of people. So some of the more advanced things in our map features are, we've got these tabs. This roads tab is where you can kind of go in and get into the details of how the roads are plotted. And for our major roads, you can set different properties for the interstates and the highways and such. City names. Now, if you've got a map where you've got, the program tries to automatically decide how many city names to show kind of based on the scale of the map, which depending on how populated of an area is may or may not show what you want. And that's on the city names tab. There's an option here. You can say, do not show cities with population less than. And so if you're not seeing enough names, you can check this and put this to a really low value. Like I'm going to change that to a 10. So we're not going to show cities with a population less than 10, but if it has a population more than 10, it should show it. So if we hit OK with that, actually didn't change our map a whole lot here. And that's okay. So let's go back here and we'll put this down to 0. And if you put this at 0, it should show all of the cities. And there are a number of cities in the database that don't necessarily have population sorted. And I guess this one we're kind of zoomed in enough that it's filled out. But yeah, you can kind of see, this has a lot of cities on here. And the last thing, Probe tries to plot these where the city names aren't overlapping. So if it finds two cities where the name's going to overlap, it will pick one or the other and plot them. You can actually disable that if we go back to our city name tab and uncheck this box to allow city names to overlap. So now you'll see, we have a bunch of cities up in here where they're all kind of merging here. But if you're looking for a particular city, this can kind of be handy to make sure you're not missing any. So that's basically that. And then you can also specify a different font and colors and such to use for large and small cities. And down here is the breakpoint, which decides. So right now this is set to anything that's bigger than a city of 100,000, it's going to use the large city font. And if it's smaller, then it'll use the small city font. The next thing we have here is the backdrop tab. There's a number of different backdrops you can do. You can show census density and scattergram and land cover. This basic terrain plot, I'm going to put this one here just to show you guys. There is a thing if you wanted to. This plot using relief shading, which this is kind of makes an interesting looking map where you've got you sort of see a semi 3D representation of the terrain. And this also brings us to an interesting point of here we've got our signal is in solid red, and so we can't really see what's going on underneath that. If you wanted to, you can change that on our display options. If we go into here, the signal strength mode, if we click this options button, and this is sort of getting in, there's a lot of kind of internal options about this, but one of our options here is our layer transparency. So right now we're on 100, so the opacity, so it's not going to let anything through. If we turn this down, like let's put it on 75, hit OK, and then OK again. So in this case, you can kind of see, like here, these hills underneath, and you can adjust this to sort of get to where you you know, depending on what you're trying to show, I'm going to turn it down a little bit more so we can see more of the underneath. Yeah, so here you can kind of see the terrain underneath the signal. So that's another fairly attractive mapping option. Turn that off. The next tab here is the raster layer tab, and I had someone ask about how that works. This is probably worth. I think the last webinar we did, I spent a good amount of time on this, so I'm not going to spend too much on it. But the raster data is sort of our rasterized data, which is basically bitmaps that kind of get strung together to create base layer maps. So there are a number of things. We have some topo maps and ortho image, which is kind of like a satellite image. So, for example, let's pick this 1 to 100,000 topo map. I'm going to hit OK on this. And now you see when we've drawn our map, it doesn't really show anything. And I'm going to zoom out just a little bit here. And this is just to explain what I'm doing here. I click on our zoom tool, and then if I right click with that, it pops up a menu so we can zoom out by a certain factor. And what you're going to see here is we get a bunch of squares. And these squares each have a file name listed, and that's the file name for the data that's in there. So what's going on here is that this raster data, the files tend to be really large and take a lot of time to load. So kind of depending on your situation, generally, if you're going to need to load a whole bunch of these files, you're too zoomed out and it's going to take a long time to load and draw the map, and that's probably not really what you'd intended. And a lot of these data sets, you know, like this is the 1 to 100,000 data set. So if we try to plot it at the 1 to 2 million scale, it's so scaled down, you're not really going to be able to make out any of the details anyway. So this is sort of a catch-all in the program where, let me go back into our map features, and on our raster tab, there's this plot map when scale is less than, and it has a number there. So that defaults, and there's actually a place in the defaults where you can set this, but if you're zoomed out too far to where it's beyond the scale that's listed here, instead of showing the map, it's going to show these squares, and that way you know that, okay, it's not loading it because, you know, and you can change this threshold, obviously, but it's a lot of times you don't necessarily want to. It kind of depends. So anyway, so if we take our zoom tool here and zoom in on a much smaller area, we'll go down to a smaller scale. And so here we've loaded our topo data, and we can see that on the map now. If we go, you know, even zoom into a smaller scale. And one of the things that's worth noting is this will actually draw the regular data with the topo data. So like our city names and stuff that are on here are actually getting drawn on top of here. And I've got this, you can see our county line coming through here, and those type of things. So kind of depending on what you want to show, there are times when you want that and there's times you don't. So you may want to go into your general tab and turn some of those things off when you're working with the topo maps. But in general, that's how it works. And basically, I just wanted to kind of mention this thing about this reference scale and how that works, because apparently for the people that haven't used that much, they're not too familiar with it. And just to answer the question of why do I see all these squares on the map, that's why. Other map feature things, this extra layers tab, this is basically just kind of extra stuff you can add to the map. And the way this works is you've got your list of available things over here, and then a list of things that are actually plotted. So right now I'm not plotting any of these. So let's say we wanted to show our ASR towers. We can select that in the list, and then these arrows is what you can use to move it from one list to another. So we'll click on this to move our ASR towers over to our plot list. And then once it's in the plot list, if you select it and hit this edit button, you have some options for the layer, and each layer will show a different window here. So for our tower plotting, there's a color, and then there's some options to show, based on the scale, what information are you going to show, and then there's some filters where you can say only show towers that are lower than or taller than a certain value. If you leave those blank, it doesn't do the filters. So that's kind of how that goes. So if we hit OK on this, it'll show us. And this, at this scale, it's configured to show the height with each tower. So if we didn't want to see that, we could go into that settings and so right now we're at like 1 to 100,000. If we go into our settings, we could make that, if we made this 60,000 for these heights, say okay. Then it's just going to show us the tick marks of where the towers are. And the last thing on here, I guess that was the data sets, but we kind of already talked about that. Basically, just sort of, you can pick the different data sets you want. For the state data, there's US only, and there's the Canada, the US only will actually just stop at the border, and so you won't see Canada or Mexico. It's a map of just the US outline. And if you pick with CAMX, then it has the data where it's got the Canada and Mexico added to it. So that's basically a rundown of what you can do in there. Other things you can do as far as making the map look good. I'm going to go in and zoom out again here so we can see a larger scale. So our signal, our grid-based signal is plotted here. If we click on our field strengths down here, and I'm going to add, and so here's where we can add new constants. You notice it says separate multiple with commas. That's sort of a probe 5 thing. So if we wanted to add, say, the 100 dBu and the 80 and 60 to this, I could put 100 comma 80 comma 60 and say okay. Then it added all of those field strengths. Now we have an option down here with some color schemes. So in this case, I have 4 cutoffs. So there's a number. If you drop this down, you can pick color scheme, and these are sort of schemes that are designed to kind of be color coordinated. So you may find this useful in picking some colors that look nice. And so what you do is you pick the set that you want and then hit apply. And now you notice it applied those colors to our field strengths. So if we hit OK on this, it's going to redraw. And, that's sort of, again, this is one of these personal preference things. I mean, this one's a little probably too dark for that purple. Let's apply. Here's a little lighter scheme. Put that in there, and that's okay, except for it conflicts with our cities, which are yellow. So maybe a lot of times I like to go in and make the metro areas be like a light gray. I think that has a pretty good look on a lot of maps. Probably not light enough there, and also our signal is being plotted transparently, so over the gray it gets darker. The other thing, making your contours look good. The contours I have on this map are just single line contours. If we wanted to edit those, we can just double click on them up in our transmitter list. And you see we've got an option to show with a color and then a border color. So right now we've just got a width of 2 line with that. So if you go in and make, like, let's make our line red and we'll have our border be, actually I'll make our line width 3 and our border width 2. We say, okay, so now we have kind of this nice thick color or nice thick contour with a black border. Those kind of things look pretty good and kind of go a long way to making your map look a little stand out a little more, I guess. And then the last sort of presentation thing I wanted to mention, you'll notice on my map here, I've got the rounded rectangles on all of the boxes. And that's something you can set on a box by box basis. For example, on our scale, if we double click on it, there's a button here, edit background border. There's a checkbox here for use rounded rectangle. There's also an option to show a shadow, so let's turn that on and we'll turn off the rounded rectangle. And so then you get a box that looks like this. So this is sort of, everybody kind of has their own opinion about what they want to see on these, but the one thing that you want to kind of be consistent a lot of times, and so there's a way to actually do that. If we go into our map, down here toward the bottom, there's an edit draw object defaults. Here's all of our draw objects, the things that we can add to the map, and we can set default values that are used for all of these here, but there's also a button down here at the bottom, apply border line settings to all objects. If we go into that, it takes us into our border editor where we can set up, how thick do you want the lines to be, and do you want to see a shadow, and so on and so forth. And if we hit OK on that, I didn't change anything. It will reset the defaults. So then the next time we go to create a map, it will default to using kind of the same style for everything. It doesn't necessarily apply it to your current map. So keep that in mind. But yeah, if going forward, then any new maps you create would have that look to it. I saw we had a question in the chat about the Longley Rice KWX errors. In general, the program, when you're working on a coverage study, so just to explain what a KWX error is, when the Longley Rice model does its thing, it has an error code, and KWX is the name of the variable, and so when it does a calculation, it may identify that the due to the geometry of the path and various other circumstances, the result may not be within the tolerance of the model, and it will set this flag to kind of indicate that. It still calculates a field strength value, but it's just sort of telling you that it may not be within the tolerance of the model. Now, in the coverage mode, essentially, the program ignores that flag. There's a case in the OET69 interference model where you're supposed to count that as interference-free coverage. In that case, when you're doing a TV interference study, there's an option in the program as to whether you're going to count those points as interference-free coverage or just use the field strength and ignore that flag. And that's sort of a, the issue is in certain areas, you can have a lot of points that have this KWX flag. So if you're just automatically counting those as coverage, that may not be appropriate. And this is sort of a detailed thing, but there is an option if we go into our display options and field strength, there's a plot KWX model error points, and you can set a color. So if we say OK, so like on this study, for example, I'm going to zoom out a little here so we can get an idea of the full thing. So all of these points that are in red here are where this KWX flag was set. So you can actually look at those and get an idea. And again, it's kind of dependent on the thing, but generally we use the KWX, or we just use the field strength that's calculated because you don't really have much of a choice to do anything else. So that is sort of how we handle the KWX. Options. I see someone sent me a direct message with a question about drawing arrows. So when you're drawing arrows on the map, there's this arrow drawing tool here, and you can you essentially click the point that you want the arrow to point to, and then click a second point, and it will draw an arrow. The question was, is there any way to get these to draw a straight line? Like, in a lot of programs, if you hold down Control or Shift, it will force the line to be horizontal or vertical. That's actually not something that Probe does at this point, but it would be reasonably easy to do that. So I will look into putting that into an update. Right now, if you wanted to have be a basically horizontal line, you can select it, and then, well, actually, yeah, this one doesn't have editing of the points either. So yeah, but we could certainly add that as an option. And the question, can you lock an arrow point to a token? Currently, you can't. If your desire in doing that is to say show a particular azimuth or something, there is a way to do that. If we go in, so like we've got our 60 dBu contour here. If we go into that, there's this additional radials to plot and show cardinal radials. So if you click on show cardinal radials, say you want to show every 5 degrees, say, okay, it's going to draw a line, you know, the azimuths at every 5 degrees. If you turn that off, say if there's a specific azimuth you want, you can just hit add here and say we want to do 23.5 degrees. Say okay. And it will, you can see it's drawn that azimuth there. But yeah, there isn't a way to lock the arrows necessarily to the token. Can you adjust the font of the county names? You can. And yeah, sorry, I'm just kind of reading these questions in the chat as they come up here, just to talk about a couple of these real quick. But so the county names, if you go into down here at the bottom, actually, I take that back. Can you adjust the font? You can't adjust the font. You can adjust the size. So if you want them to be bigger, you can make the size larger. So like back here, we have this Man County. If I change that to a 3, you notice it's got, or that's Marin County, I guess, but you notice it gets bigger. But yeah, I guess there is not necessarily a way to change the font of those as it stands now. I can look into that as well. All right, and then I see there was one other question about doing a Longley Rice contour, which is, I guess while we're in here, we can talk about that real quick. So we were working with our 70 dBu Longley Rice, you know, the grid-based thing. There are times when you might want to clean up our map while I'm talking here. There are times when you might want to make like an actual distance to contour type of contour using the grid-based Longley Rice signals. So the way you can do that is actually you just add a contour, which is right here, add contour. And then for the contour type, there's a calculated signal contour. So in this case, you give it a field strength. So like we were looking at the 70 dBu before, I'll put that in here, and then a calculation method. So essentially the 3 methods is first occurrence, last occurrence, and mean occurrence. So first occurrence is it'll look at each radial, and when it gets to the first time it drops below your specified signal level, that's where it will set the distance to contour. Last occurrence, it'll look at a specific radial, and the last point on the radial where that field strength occurs, that's where it will set the contour. And the mean occurrence is essentially the average between those two. So for example, 70 dBu will do a last occurrence contour here. We'll make that, let's make that green. Say, okay. So here, and I'm going to make a border on that so it's a little bit easier to see. So here we've got, essentially, this is showing all the points where the last occurrence of our 70 dBu signal happened. You can go back here and change it to the first occurrence. So essentially the last occurrence is your most optimistic case, and your first occurrence is going to be your least optimistic. So generally, if you're within this contour, you should be, you will definitely have a 70 dB signal on that azimuth. So that's basically how you do it. And then, like I said, the mean occurrence, it just averages the two. If you wanted to get a report of this and see, you know, what are these distances, if we right click on our contour up here on the list there, actually, we don't want that one. We want, what I wanted to show you here was if you right click on the transmitter, there's an option to show contours in DTC window. So this actually pulls up a table here where we can see, you know, for each azimuth, it has the power in that direction. This is a omnidirectional, so it's the same for all of them. It has the height above average terrain, and then for each contour listed. So in this case, we have the 60, 70, and then our second 70 here is our calculated one. So it goes out 38.1 kilometers, whereas the FCC contour only went out 20.8. So in this case, Longley Rice is essentially predicting the field strength, or it will go out further than the FCC model. It looks like that was for 0 degrees. So that's kind of this one where we're out over the water for most of it. So that kind of makes sense. And it does kind of depend on the azimuth in the area you're in, whether or not it's going to go out further or not. A lot of times, if you're in a reasonably flat area, the Longley Rice will go out further than the FCC contour. Other things, I had somebody send me an email and ask about doing, or ask about explaining the urban clutter factor. And so this is a more advanced thing, and I'm going to go ahead and turn these contours off here for a minute, but there's an option in here on our transmitter thing. So we pick our propagation model here, and there's a number of propagation models the program supports. You can use Longley Rice, which is kind of the most common one. There's this FMPTP is another point-to-point model that was developed by the FCC at one point. The FCC model is actually the FCC contour model, so you can use that as a grid-based model. And then this OH loss is this National Spectrum Managers Association propagation model, and it's another point-to-point model. So the different models kind of allow you to do different, they're all similar. They're all calculating field strength, but they kind of take different approaches. So if you're trying to get maybe a second opinion, you can try some of the other models. And they each kind of have their own limitations and things. But Longley Rice, when you're working with that, and depending on the model you have selected, there'll be a different tab up here. If I were to pick the OH loss model, you notice there's an OH loss tab up here where the properties for that model are. So to go back to Longley Rice, if we go on here, Longley Rice parameters. Here's sort of the inputs to the model. And so one of them, we have a checkbox here, use urban clutter factor. So what is that and why would you use it? The urban clutter factor is, there was a paper written by Anita Longley called Radio Propagation in Urban Areas, where basically she looked at comparing the results of the Longley Rice model to the measurements and the model that Okamura came up with, kind of based on those measurements, and generated sort of this adjustment factor that you can apply to Longley Rice to make it match the Okamura measurements. So basically, it's an urban thing, so it's going to generally attenuate the signal quite a bit, and it's a fairly simple formula that does the adjustment, and it's basically as you move away from the transmitter site, the urban clutter factor has less of an effect. But if we wanted to see, actually, I wanted to make a map that kind of shows, I wanted to show you guys how the difference between using the urban clutter factor and not using it. So what I'm going to do here is go in, and one of the windows we haven't talked about yet is the study edit window. There's this icon next to the map features, or if you go to view, edit, study, this is sort of where all of these options that we configured in the wizard are accessible from within the study. So if you wanted to change anything about the study options you used or any of that, so in this case, I'm going to go ahead and add, and I'm going to load our same station in here, KALW again. And it will default to copying the parameters from the first one, which is kind of what I want. And then I'm going to go on the Longley Rice, kind of check this huge urban clutter factor. And I'm going to change our call sign on it to be, call it UF for urban factor, just so I can easily tell them apart. So if we hit OK on this, and hit OK again, it's going to calculate this. So now we're going to see we have two KALWs, and right now this map isn't necessarily so much meaningful. It's plotting the highest field strength of the two, and this first one is always going to be higher. So essentially we're just looking at a map of that. You have to go into a draw mode here. If we hit our display options, there's this draw modes. So transmitter color is one of the options. The transmitter color will essentially plot based, well, if we click on options, there's some options here. So it asks for the field strength to draw. So in this case, let's look at the 70 dBu again, because we were looking at that before. So this is going to draw the signal is 70 dBu, and then there's a plot method. You can do it based on the highest field strength, in which case it's going to use, you see each transmitter has a color. One has this light blue, kind of cyan, and the other one's red. So it'll plot whichever one has a higher signal in that color when you use highest field strength. Like I just mentioned, we don't necessarily care about that now because the light blue one's always going to be higher because it doesn't have the additional attenuation in it. But the second option here, order and transmitter list, in this case, it's going to plot the light blue, and now it's going to plot the red for this other one on top of that. So that's going to show what we're looking to see here. So if I hit OK, hit OK again, there's that. And I'm going to go in here and turn up make these a little less transparent so they're not so dark. There we go. So now we can see here, essentially all the area in red is where the Longley Rice using the urban clutter factor is predicted to receive a 70 dBu field strength. And all the area in blue is where, if you don't consider the urban clutter factor. So essentially, you know, in an urban environment, you know, your 70 dBu may fill in this red area, and you may or may not have reception in the blue area. So you can see it's about, for an FM station, you know, it's about a 16 dB of attenuation close into the transmitter. And then as you get out, it trails off to less, but you can see it makes quite a difference. Now you have to be a little bit careful in this, in that, you know, there's times when it may be appropriate to apply this and there's times when it isn't. The Okamura measurements are, you know, were done basically in kind of an urban broadcast to urban reception environment. So you're looking, you know, if your antenna is in an urban area and you're broadcasting to locations in that urban area, it may be a fairly valid adjustment to make and consider the urban clutter factor. If you've got a really tall antenna that's, you know, outside of a city and you know, kind of going into the city, you know, in that case, it may or may not really be appropriate to use the urban. It may actually attenuate more than in real life what you're going to see. So this is sort of a judgment deal. You have to kind of determine if the situation you're looking at is right for that. I see we're getting to be about 11 or 12:35 here Eastern time. So I kind of was hoping to keep this to around an hour. So I've covered a number of things. I guess one last thing, I did have a couple slides prepared for a question somebody had sent me, which was talking about dealing with the cell size. So one of the options on here is the cell size, and that's essentially the grid is calculated as a grid of cells. And you can kind of see, if you go into this map and special effects, I've got this interpolate signal values, which is essentially for each cell, it's going to, when it's looking at a point in between two cells, it'll interpolate the value. If you turn that off, then it's going to just treat each cell as, you know, whatever field strength is calculated for the cell. And if we zoom in here, we can kind of get an idea of, you know, how big these cells are. So when it's calculating this, you know, it's going from the transmitter to the center of that cell and then the center of that cell. And so it gives you an idea there. And so the question is, you know, what's an appropriate cell size to use? And there's sort of a number of factors that come into that. But as far as one thing to think about when you're working with the cell size, and this study, I used a 1 kilometer cell size, which will generally, you know, the advantage of that, it calculates very quickly and it doesn't require a ton of points, and you know, the program works pretty well with it. As you reduce that cell size, it needs to calculate more points. And I put together a couple slides here. Let me go to this. So the number of cells required to be calculated increases significantly with smaller cell size. And I kind of made an example of, if we're looking at an area where our coverage area is 100, you know, the calculation area is 100 kilometer circle. Well, to do 1 kilometer cells, you're basically going to have roughly a 200 by 200 grid, which means that you're going to need to calculate 40,000 cells of data. And that's something the program can do and handle and work with very easily. If you go down to a 0.5 kilometer cell, that means for that same calculation area, you're looking at a 400 by 400 grid, which comes out to about 160,000 cells. And if you get down to a 0.25 kilometer cell, then you're looking at an 800 by 800 grid, which is going to require the calculation of 640,000 cells. So you can see the number of cells required becomes, considerably larger as you go down in cell size. And then our next thing here, so just to give you an example, going from a 1 kilometer cell to a 0.5 kilometer cell essentially is going to increase the number of cells by 4, a factor of 4. So your calculation time is going to go up by a factor of 4, which is fairly reasonable. When you get down to go from a 1 kilometer cell to a 0.25 kilometer cell, you're going to see that your calculation time increases by a factor of 16. So if you had a study that took a minute to calculate at a 1 kilometer cell, you're going to be at 16 minutes for a 0.25 kilometer cell. So it's sort of and as you get into more cells, your files are going to get larger, and there's some aspects of the program, the more cells you have, it'll take longer to calculate and work with some aspects of the program. So I know there are a lot of people that like to do a super tiny cell size and are willing to wait for it, and the program will let you do that. So just to kind of give you an example here, to go into the study edit window, let's change this from a 1 kilometer cell down to a 0.5 kilometer cell. And we'll let that recalculate, and we can see how that looks differently on the map. So it's sort of, and as your calculation area, if you're going out beyond 100 kilometers, say you're doing a 200 kilometer study, that also will increase the number of cells considerably. So I would say, what cell size you should use is at least partially dependent on how far out you're going to calculate. The further out you're going, you should be using larger cells. If you're just looking at a smaller station that maybe only goes out 20 or 30 kilometers, using a smaller cell size is probably appropriate. So here we can kind of see how the smaller cell size looks on this, and it's less granular than it was before. So my opinion, for a bigger area study, I think 1 kilometer is a reasonable size to use. You can go down and do the 0.5. That's also still reasonable to work with. But once you get below sort of a ½ kilometer cell size, it starts to become a little bit, problem. I don't know what problematic, but it definitely takes longer, and you're going to end up with huge files and all that. So you kind of have to use your judgment. So yeah, I would say for a larger area, 0.5 or 1 kilometer is a decent size to use. If you're doing a smaller area, you could go down to the 0.25 or maybe lower, and it'll work just fine. But again, this is one of these deals where it's kind of dependent on what you're trying to show. And one of the things to keep in mind with these predictions they are just predictions. There is some room for error, not like error in terms of like error bars. As you make the cell size smaller, yes, it's computationally more accurate, but in terms of real world, matching the real world, it may or may not necessarily be more accurate making it smaller. There's the results that Longley Rice predicts, we're not considering everything. We don't consider the trees and the buildings and all these things. So there's always going to be some the error bars are fairly large in terms of what is calculated versus that. So you may be gaining resolution in a computational sense by going down to a smaller size, but you're not necessarily gaining accuracy in terms of real world accuracy. So that's that one. All right. What else did I have? I think that's basically what I wanted to talk about today. Go back through this again. The last thing I just wanted to mention was, and you've probably heard of this on our next slide here, we're having the big sale for the month of April. We're not attending the NAB show this year, so we're passing the savings of what it would have cost us to do that on to you guys by doing a 25% sale on all of our software and new database purchases. There's a link there that you can use to we have a price list with some of the specials on there, or give us a call and we can give you a quote for whatever you're looking for. And beyond that, I just want to say thank you for coming. And if you guys have any questions or whatever, you feel free to contact us, and we're always happy to answer those.